Okay. Can you see the screen?
Yes,
Screen
sir.
दिसते तुम्हाला?
Yes, sir.
Okay. So the first definition is, okay, what is the first definition? The silo P subgroup. Silo or the silo P subgroup. The definition of silo P subgroup. Okay. What is the definition? Look at here. Silo P subgroup. So what says if order of a group G is equal to P raised to n into m. Okay, if the order of the group G is in the form of P raised to n into m, such that P does not divide m. Okay, this P is not divides m. याचा अर्थ काय? या m मधून P हा फॅक्टर बाहेर येत नाहीये. Okay, so GCD of P and m must be equal to 1. Okay, such that P does not divide m, then the subgroup of a group G, the subgroup, look at here, the subgroup of a group G, subgroup of a group G of order P raised to n, okay, will be a sylow P subgroup, a sylow P subgroup. Okay, sylow P subgroup in G. Okay, so this is the definition of sylow P subgroup. What it says that if order of G is nothing but P raised to n into m, such that P does not divides m. What it means? P does not divides m. This means that the P is not the divisor of this m. Okay. या P आणि m चा जीसीडी किती असायला पाहिजे? 1 असायला पाहिजे. Okay. Then the subgroup of a group G of order P raised to n, जो काही सबग्रुप असेल P raised to n या ऑर्डरचा, will be a sylow P subgroup in G. Okay, so this is the definition of sylow P subgroup. Okay, this sylow P subgroup is also called as PSSG. Okay, या ह्यालाच नाव काय? P sylow subgroup. Okay, sometime it called as PSSG or sylow P subgroup. Okay, any doubt up to here? Any doubt up to here?
No, sir.
Okay. So one note is there. Okay. Note one. First one. What is the first note? A sylow P subgroup is a sylow P subgroup. Okay. Sylow P subgroup of a group G, of a group G is a maximal, okay, maximal P subgroup of G. What it means? Okay, a sylow P subgroup of a group G. या ग्रुपची ऑर्डर किती असणार? P raised to n. That group is a maximal P subgroup of G. Okay, म्हणजे जो काही P raised to n चा जो sylow P subgroup असेल तो कसा असेल? मॅक्झिमल P subgroup. मॅक्झिमल सबग्रुप असणार कोणाचा? G चा. Okay, so this is the first note. So second note is there. What is the second note? If capital P, okay, not a prime number, okay, this is the capital P, is a sylow P subgroup. Okay, then the small g belongs to capital G. Then order of G capital P G inverse is equal to order of capital P is equal to P raised to n. Okay, हा जर capital P जो आहे, this is the capital P. Okay, capital P is there. So what is the order of this P SSG sylow P subgroup ची order किती असणार? P raised to n असणार. आता G into P into G inverse. What it means? The conjugate subgroup of this P. Okay, we know that if suppose A and B are two subgroups of H, then A is conjugate to B when A is equal to G, B, G inverse. Okay. So then we say that A is conjugate subgroup of B. Okay. This is the definition of conjugate subgroup. माहिती आहे ना? If A and B are the two subgroups of G, then A is equal to, if A is equal to G into B into G inverse, then we say that A and B are conjugate subgroup of each other. Okay? Any doubt? म्हणजे या P ची जेवढी काय ऑर्डर असेल त्याच्या कॉन्जुगेट सबग्रुप पण काय असणार तो, या P चा जो कोणी कॉन्जुगेट सबग्रुप असेल हा G into P into G inverse, तो पण काय असेल सायलो P सबग्रुप. ओके, आणि त्याची पण ऑर्डर किती असेल P raised to n. ओके, एनी डाउट?
No, sir.
Okay, so we will move towards the sylow first sylow theorem. Look at here. What is the statement of this? First sylow theorem. First sylow theorem. What is the statement? Look at it. First sylow theorem. Okay. Statement. Very, very important theorem for your semester. Okay. Look at here. Let G be a finite group. Let G be a finite group. Okay. With order of that group G is equal to P raised to n into m, where P is prime. P is prime number. Prime number. Okay, and P does not divide this m. Okay, and n is greater than or equal to 1. Okay, P does not divide m and n is greater than or equal to 1. So then first, what is the first? Then first G contains a subgroup of order P raised to I for each I, where I running from 1 to n. Okay, I is running from 1 to n. Okay, so this is the first statement. G contains a subgroup of order P raised to I for each I. That means where I running from 1 to n. So what is the second statement? Second condition is there. Second condition. Every subgroup H of G every subgroup H, okay, of G of order p raised to I, of order p raised to I is normal subgroup of normal subgroup of normal subgroup of order p raised to I plus 1, where here I running from 1 to n minus 1. Okay, n minus 1. Or if we can take 1 less than equal to I less than n. Okay, we take this condition also. Okay, what's is the statement? Look at here. If G is the finite group, okay, with order of G is equal to p raised to n into m, where p is the prime number and p does not divide m. It means that the GCD of that p, prime number p and m is 1. Okay, म्हणजे या m मध्ये कोणताही p चा फॅक्टर नाहीये and n is greater than or equal to 1, then the G contains a subgroup of order p raised to I. या G मध्ये p raised to I चा एक सबग्रुप पाहिजे, ज्याची ऑर्डर किती पाहिजे? p raised to I. Okay, where I running from 1 to n, and every subgroup H of G of order p raised to I, जो कोणी हा सबग्रुप असेल p raised to I ऑर्डर असलेला, is normal subgroup of order p raised to I plus 1. हा H हा जो सबग्रुप असेल तो नॉर्मल असेल कोणामध्ये? त्याची ऑर्डर p raised to I plus 1 आहे, where I running from 1 to n minus 1. Okay, so this is the statement of this theorem. Okay, any doubt? Any doubt in the statement?
No, sir.
Okay, so we will move towards the proof. So part 1 statement, दोन स्टेटमेंट आपल्याला प्रूव्ह करायचे, त्यातलं पार्ट 1. Okay, look at here. This is the part 1. So we will prove this theorem by mathematical induction. We will prove this theorem by mathematical induction. Okay, mathematical induction on I. Okay, so step number 1 in part 1, step number 1. Okay, what is the step number? Prove that the result is true for I is equal to 1. Prove that the result is true for I is equal to 1. Okay, so what we have? The order of G is equal to what? P raised to n into m, which implies P divides that order of group G. Okay, which implies that by Cauchy theorem, by using Cauchy theorem. What is the Cauchy's theorem? If order of P divides order of G and G is the finite group, then by using Cauchy's theorem, there exists a subgroup. There exists a subgroup, say H, okay, of G, such that order of H is equal to P raised to 1 is equal to P. Okay, so order of H is equal to P. By using Cauchy theorem, there exists a subgroup, say H of G, such that order of H is equal to P. Any doubt up to here? एनी डाऊट? समजतंय का
नो
काय?
No,
सर.
sir.
ओके. जसं मी सांगत जाईन तसं लिहून पण घेत चला, पुन्हा लिहायला वेळ लावत जाऊ नका. ओके. सो स्टेप नंबर 2 नाव. व्हॉट इज द स्टेप नंबर 2? Step number 2. Okay. What is the step 2? Assume that. Assume that the result is true. The result is true for for I less than n. Okay, suppose this result is true for I is less than n. nच्या प्रत्येक व्हॅल्यूला हे nच्या लेस दॅन nच्या प्रत्येक व्हॅल्यूला I च्या हे रिझल्ट ट्रू आहे. ओके, by using this assumption, by using this assumption, there exists a subgroup. Okay, there exists a subgroup, say H, such that order of H is equal to P raised to I, where I is less than n. Okay, any doubt? This is the
No, sir.
हायपोथेसिस. ओके, आपण हे हायपोथेसिस अझम्पशन केलंय आणि स्टेप 3 मध्ये काय प्रूव्ह करायचंय? दिस इज प्रूव्ह फॉर आय इज इक्वल टू आय प्लस 1 साठी हे स्टेटमेंट ट्रू होते, हे आपल्याला प्रूव्ह करायचंय. ओके, सो व्हॉट इज द स्टेप नंबर 3? लुक एट हियर. दिस इज स्टेप नंबर 3. Step number third statement. Third step. Prove that there exists a subgroup of G, a subgroup of G whose order is P raised to I plus 1. Okay, we have to prove this one. By using step number 2, we have to prove this one. Okay, now assume H is a subgroup of G, okay, H is the subgroup of G such that order of H is equal to P raised to I, where I is less than n. Okay, we assume the statement in step number 2. Give it as equation number 1. Okay, now consider the index of H in G. Okay, is nothing but order of G upon order of H. Okay, is equal to, or what is the order of G? P raised
P
to
raised
n
to n into m.
m. Okay, very good. And what is the order of H? P raised to
P raised
I,
to I.
which is equal to P raised to n minus I into m. Okay, where this I is less than n. Okay, what happens if I is equal to n? जर I हा n झाला तर काय होईल? n minus n is 0. ओके, काय होईल? वेट अ मिनिट, सांगतो. ओके, लुक एट हियर. इफ I is equal to n, जर हे झाला तर काय होईल? n minus n 0, p raised to 0 1, which is equal to m. Okay, so p does not divides index of p does not divides here m, hence p does not divides index of h in G. Okay, look at here, it implies that p divides, we know that n मायनस आय इंटू यम. ओके, या नंबरला पी डिवाइड करतो की नाही? करतो. हेन्स इट इम्प्लाइज दॅट पी डिवाइड्स index of h in g. Okay, any doubt up to here? And also we have p divides order of g. Any doubt up to here?
No, sir.
Okay.
No, sir.
Now we have, by in the previous theorem, we seen that the one theorem is there. We have index of h in nh. Index of h in nh is concurrent to index of h in g mod p. Okay, we have this theorem, which implies that p divides index of h in g minus index of h in nh. Okay, any doubt up to here?
No,
No,
sir.
sir.
इकडे बघा आता या स्टेटमेंट, पी कोणाला डिवाइड करतोय? इंडेक्स ऑफ जी, इंडेक्स ऑफ एच इन जी. इथे पी कोणाला डिवाइड करतोय? सबट्रॅक्शनला डिवाइड करतोय. हे दोन जर इक्वेशन ऍड केले तर पी मस्ट बी डिवाइड्स द ऍडिशन ऑफ दिस टू वन. ओके, सो व्हॉट वी गेट देन ऍडिशन इंडेक्स. So we have to get here p must be divides index of h in nh. Okay, any doubt?
No,
Must.
No,
sir.
sir.
त्या दोघांची ऍडिशन केली राईट हँड साइड, तर पी मस्ट बी डिवाइड्स इंडेक्स ऑफ एच इन एन एच. ओके,
सर,
सो व्हॉट वी हॅव
स्टेटमेंट मध्ये पी डज नॉट डिवायडेड बाय एम असं होतं. मग इथे वरती वी हॅवच्या वरती एक स्टेप आहे, पी डिवायडेड बाय पी रेस टू एन मायनस आय इंटू एम. त्यामध्ये एम आहे ना?
आहे की, म्हणजे एम आहे की. हा पी एम ला डिवाइड करत नाही, हा यांचा दोघांचा मल्टिप्लिकेशन आहे. पी रेस टू एन मायनस वन ह्या फॅक्टर मध्ये पी आहे की नाही?
हो.
प्राईम नंबर आहे ना, मग हा पी याला डिवाइड करतो की. इकडे पहा, पी मस्ट बी डिवाइड्स दिस मल्टिप्लिकेशन. 3 हा 3 इंटू 2 ला डिवाइड करतो की नाही? 6 ला डिवाइड करतो की नाही? 3 हा एलिमेंट, 3 हा नंबर
हो.
6 ला डिवाइड करतो, 3 इंटू 2 ला
हो.
डिवाइड करतोय. लुक ॲट इट. सपोज पी 3 आहे, पी डिवाइड. ओके, आता काय डाऊट?
हा, समजलं.
समजलं? ओके.
हं.
याच्यामध्ये फॅक्टर आहे ना, पीचा फॅक्टर, संपला विषय. सो पी मस्ट बी डिवाइड्स दिस वन. ओके, एनी डाऊट अप टू हियर? P must be
No,
divides
sir.
index of h in nh. So hence we have P divides order of nh upon order of h. Okay. Okay. आता हा तुमचा फायनाइट ग्रुप आहे, which is equal to what? What is the order of n of h अपॉन एच. दिस इज द क्वोशंट ग्रुप. हो ना, हा तुमचा क्वोशंट ग्रुप आहे. आता पी ह्याला डिवाइड करतोय ऑर्डर ऑफ एन एच अपॉन एच. ओके, एनी डाऊट? हा याची ऑर्डर फायनाइट आहे आणि पी हा कोणाला डिवाइड करतोय? एन एच अपॉन एच ला, म्हणजे हा तुमचा क्वोशंट ग्रुप आहे. देन अगेन बाय युजिंग कॉची थेरम वी हॅव, इफ any prime number divides the order of that group, then there exists a subgroup whose order is p. Okay, so we have, there exists a subgroup of G नहीं आता इथे, G नहीं आता इथे, काय येणार? NH of H से K. ओके, हा समजा K तुमचा सबग्रुप आहे. कोणाचा? याचा. such that order of that capital K is equal to P. Give it as equation number 2. Okay, any doubt?
No, sir.
जर
No, sir.
एखाद्या ग्रुपला जर पी ने डिवाइड होत असेल त्याच्या ऑर्डरला, तर कॉची थेरम काय सांगतोय? देयर एक्झिस्ट अ सब ग्रुप ऑफ दॅट ग्रुप. ओके, नाव हियर NH अपॉन H इज द क्वोशंट ग्रुप. क्वोशंट ग्रुप आहे तुमचा. कोण आहे तुमचा? त्याचा सब ग्रुप के आहे. मग के पण कसा असायला हवा? हा क्वोशंट सब ग्रुप असायला हवा. ओके, Now look at here. We know that we know that subgroup of quotient group is quotient. Okay, so this K must be a quotient group. Okay, इथे लिहून ठेवतो मी. K is the quotient group, capital K. Hence, hence K is the quotient group containing H. K is quotient group containing H. Why H? So look at here. What is the identity of this group? NH upon H.
H.
H. NH हा H हा NH मध्ये आहे. H is NH contains H. Okay. Similarly, here the K is the subgroup of this quotient group. Hence, this K is the quotient group containing H. हा H कोणामध्ये असणार? K मध्ये असणार. Okay. Okay. Any doubt? इथपर्यंत
No,
काही डाऊट
sir.
आहे का? ओके. आता ह्याच्या पुढे आपल्याला एक मॅपिंग डिफाइन करायचं आहे. कन्सिडर canonical map. Canonical is nothing but onto homomorphism. Okay. Canonical map, that nothing but onto homomorphism map. Okay. Such that gamma of n of h to gamma is the mapping from n of h to the quotient group n of h upon h. Okay. Such that gamma of x is equal to hx. Okay, we know that this mapping is onto homomorphism. Okay, always. Okay, for all x belongs to where? N of h, na? This x is nothing belongs to n of h. So this is the mapping which is onto homomorphism. We know that. Okay, now look at here. Now, K is the subgroup of n of h upon h. Okay, K हा कोणाचा सबग्रुप आहे? n of h upon h, which is the quotient subgroup. या quotient subgroup ची पण आयडेंटिटी काय असायला हवी?
H.
H असायला हवी. Okay, so H is always contained in this quotient group. Okay, K. Okay, such that this H is contained in K. Now, if suppose gamma is the mapping from n of h to n of h upon h, then this mapping is onto homomorphism, we know. Okay, then gamma inverse हे mapping कुठून कुठून येणार?
N of H upon H to N of H.
H upon h to h, sorry, n of h. Okay, any doubt?
No,
लिहायची
sir.
गरज नाहीये, ते लक्षात ठेवा. Okay, the gamma inverse is the mapping from n of h upon h to n of h. Okay, now we know that here the h is contained in K. Okay, so what we have, the gamma inverse of h is always contained in gamma inverse of K. Okay, look at here, we know that h is contained in a K. हा h तुमचा कोणात कंटेन आहे? K मध्ये कंटेन आहे. Okay, so the gamma inverse mapping घ्या दोघांचे. तो gamma inverse h is contained in gamma inverse of K. Okay, so but what is the value of gamma inverse of h? So gamma inverse of h, gamma inverse ची आयडेंटिटी आहे. Okay, या ग्रुपची आयडेंटिटी गॅमा इनवर्स आपण आयडेंटिटीवर मॅप हे करतोय, मॅपिंग घेतोय, आयडेंटिटीवर मॅपिंग. सो इथं काय येणार, गॅमा इनवर्स ऑफ एच इज नथिंग बट एच. Since H is contained in N of H. You know that here. H is contained in N of H. We seen in the previous lecture. The normalizer of H is always the subgroup of H is subgroup of normalizer of H. Okay, this is the largest subgroup of H such that H is normal in N of H. Okay, so here we have gamma inverse of H is nothing but H. ओके, ह्यामध्ये जो मॅप आहे याची आयडेंटिटी एच, हे कुठे मॅप होणार, इकडे एच ला मॅप होणार. ओके, सो एच इज द सब ग्रुप ऑफ गॅमा इनवर्स ऑफ के. ओके, इकडे के हे तिचे के हे एच कोण आहे, एच इज कंटेंड इन के, रादर एच इज सब ग्रुप ऑफ के. Okay, why? Here the identity is there. Is the singleton identity is the subgroup of this quotient group. हा तुमचा quotient group आहे. ओके, हे जे आहे तुमचा quotient group आहे K. ओके, याची आयडेंटिटी काय असणार, H असणार. So H singleton identity is the subgroup of this quotient group. Hence the gamma inverse mapping H is the subgroup of gamma inverse of K. Okay, हे most important, हे कसं आलं हे समजायला पाहिजे. Okay, any doubt up to here?
No, sir.
Okay,
No, sir.
look at here, where gamma inverse हा सेट कसा असेल, gamma inverse of K is nothing but set such that X belongs to N of H such that gamma of X is equal to capital K. Okay, any doubt? Gamma inverse of K हा सेट कसा असेल, हा तुमचा K इथे आहे, K हा याचा सबग्रुप आहे N of H अपॉन H चा. याची मॅपिंग कुठे येते, N of H मध्ये येते. म्हणजे गॅमा इनवर्स ऑफ H हा जो मॅप आहे गॅमा इनवर्स K हा कुठे असणार, X बिलॉंग्स टू N of H, ह्याचा सबग्रुप असणार. ओके, so gamma inverse of K is the subgroup of N of H. Okay, so X belongs to N of H such that gamma of X is equal to K. Any doubt?
No, sir.
And now look at here. जर K हा तुमचा याचा सबग्रुप असेल N of H अपॉन H चा, तर गॅमा इनवर्स ऑफ K कोणाचा सबग्रुप असेल, N of H चा. ओके, hence we have gamma inverse, sorry, here the gamma inverse of capital K is the subgroup of normalizer of H, but which is the subgroup of G. Any doubt? नीट समजून घ्या, मॅपिंग कुठून कुठपर्यंत आहे. गॅमा इनवर्स ऑफ K कुठे येणार, N of H चा सबग्रुप येणार. So we have gamma inverse of K which is the subgroup of normalizer of H, which is, but normalizer of H is the subgroup of G. Now also here the H is the subgroup of gamma inverse of K. Okay, from this one. Okay, any doubt?
No, sir.
Now we have one theorem is there using. Now one theorem is there, result is there. Okay, what is the result? If N is normal in G, okay, then G by N is the quotient group. Is the quotient group, and H dash is the subgroup of G by N. H dash is the subgroup of G by N. So H dash is the quotient group. Okay, is the subgroup of G by N. Then there exists a subgroup there exists a subgroup H of G such that H dash is equal to H by N. Okay, we have this result. If, look at here, if N is the subgroup, N is the subgroup of G, then this G by N is the quotient group. Okay, this G by N is the quotient group. Why? Because N is normal in G. And H dash is the subgroup of G by N. समजा हा H dash तुमचा क्वोशंट ग्रुप आहे G by N चा. तर असा एक सब ग्रुप एक्झिस्ट होतो कोणाचा G चा, such that this H dash is equal to H by N. Okay, so using this method here we have create the okay, so we have here that is here the H is normal in N of H. Okay, H is normal in N of H. Then N of H upon H, हाच रिझल्ट यूज करायचा आपल्याला वरचा रिझल्ट. N of H upon H is quotient group. Quotient group. And K is the subgroup of this one, N of H upon H. We proved. Okay, this is the quotient group of N of H upon H. Then there exists a subgroup gamma inverse K. Okay, gamma inverse K of N of H such that K is nothing but gamma inverse of K upon H. Okay, हाच रिझल्ट आपण इकडे यूज केलाय. Look at here. In place of N, here is H is normal subgroup of N of H. In place of G, we taken as N of H. Okay, so here the N of H upon H is the quotient group. Okay, now we also proved that the K is the subgroup of N of H upon H. Okay, so here we have K is the subgroup of N of H upon H. Then by using this result, there exists a subgroup gamma inverse of K of which one? N of H. Here we proved gamma inverse of K is subgroup of N of H. Okay, there exists a subgroup this one of N of H such that this K is nothing but gamma inverse of K upon H. Okay, any doubt?
No, sir.
No, sir.
No, वापरलेला आहे. Okay, so hence we get implies that K is equal to gamma inverse of K upon H. Okay, which implies that order of this K is equal to order of this quotient group gamma inverse of K upon H. Okay, which implies that order of K is equal to order of gamma inverse of K upon order of H, which implies that order of gamma inverse of K, okay, is equal to order of H into order of K. Okay, so here which implies that order of gamma inverse of K is equal to what is the order of H from statement number 1. What is the one here? Look at here. The
P
order
raised to
of
I.
H is P raised to
P.
I. And what is the order of K from 2?
P.
P.
P. Means we get P into P raised to I into P, which is equal to P raised to I plus 1. Okay, here we get order of H is equal to P raised to I, and order of gamma inverse of K is equal to P raised to I plus 1. Okay, here the reason is given from 1 and 2. Okay, from 1 and 2. Here we have then order of H is equal to P raised to I, and order of gamma inverse of K is equal to P raised to I plus 1. Okay, thus there exists a subgroup of G. Okay, this is the subgroup of G now, gamma inverse of K. Look at here. Gamma inverse of K is the subgroup of N of H, which is subgroup of G. Hence, the gamma inverse of K is the subgroup of G. Okay. There exists a subgroup of G, whose order is P raised to I plus 1. Hence, from step 1, 2, and 3. Okay, mathematical induction प्रूव करते हैं ना आपण I plus 1 साठी. The result holds for all I. The result holds for all I. Okay, any doubt?
No, sir.
No, sir.
Hence, G contains a subgroup. Okay, G contains a subgroup of order P raised to I for each I, where I running from where I running from 1 to n. Okay, any doubt? इथपर्यंत काय आता हे पार्ट 1 प्रूव्ह झाला. आता पार्ट 2 प्रूव्ह करायचं आपल्याला. स्टेटमेंट नंबर 2. लुक ॲट हियर. So we prove the first statement only. The result is true for here. G contains a subgroup of order P raised to I for I running from 1 to n. Now in the second part, we have to prove every subgroup H of G of order P raised to I is the normal subgroup of order P raised to I plus 1. Okay, where I running from 1 to n minus 1. Okay, look at this. Now part 2. Okay, इथून काय डाऊट आहे का कोणाला?
No, sir.
Okay. Now the second part 2. Okay, part 2. From previous part, we have from part 1. H is subgroup of gamma inverse of K. Okay, we taken H is the subgroup of gamma inverse of K here. Where is coming there? Okay, H is the subgroup of gamma inverse K. Okay, we have that is H is the subgroup of gamma inverse of K, which is the subgroup of normalizer of H, but which is the subgroup of G. We have this one. Okay, and order of H we have P raised to I and order of gamma inverse of k is equal to p raised to I plus 1 we proved in the previous part. Hence, there exists a subgroup, there exists a subgroup of G whose order p raised to I plus 1 contains a subgroup of G contains contains a subgroup of G whose order p raised to I. Okay, we proved this one is the in the previous part. Here the gamma inverse k. Okay, here the h. What is the order of this one? P raised to I. What is the order of this one? P raised to I plus 1. Okay, so there exists a subgroup of order p raised to I plus 1 contains याच्यामध्ये कोण कंटेन आहे h कंटेन आहे a subgroup of order g whose order is p raised to I. This is proved in the previous part. Now to prove that h is normal in gamma inverse of k. ओके, आपल्याला हे प्रूव्ह करायचं आहे. हा जो p रेस टू आय चा जो सबग्रुप असेल तो कोणामध्ये सब नॉर्मल असेल p रेस टू आय प्लस 1 मध्ये. ओके, नाउ लुक एट हियर. We know that what we know? We know that when result is also is there. Okay, what is the result? If H is normal subgroup of normalizer of H, okay, and gamma inverse of K is the subgroup of normalizer of H, such that H is contained in gamma inverse of K, which is contained in normalizer of H. Okay, which implies that H is normal in gamma inverse of K. Okay, why? Since we are using this result. Which one? If H is contained in K, is contained in G, such that H is normal in G and H is the subgroup of K, which implies that H must be normal in K. So this is the result we used this. Okay, हा result आपण यूज केला. If H is subgroup of K, which is subgroup of G and H, तर हा H याच्यात नॉर्मल असेल तर हा ऑटोमॅटिकली H कोणामध्ये नॉर्मल होतो? K मध्ये नॉर्मल होतो. ओके, एनी डाउट?
नो सर.
Okay.
No, sir.
So this is the proof. Hence the proof. Hence the proof. Okay. So every subgroup H of G of order p raised to I. ह्याची ऑर्डर किती आहे? p raised to I. ह्याची ऑर्डर किती आहे? p raised to I plus 1. Okay, so every subgroup H of G of order p raised to I is normal subgroup of a subgroup of order p raised to I plus 1, where this I running from 1 to n minus 1. जर हे लेस दॅन इक्वल असेल तर n minus 1. जर ओनली लेस दॅन n लेस दॅन इक्वल असेल तर n. ओके, सो this is the proof of the theorem. So this is the first silo theorem. Okay, now two more theorem is there, second silo theorem and third silo theorem. Okay, so any difficulty? बघा पुन्हा एकदा स्टेटमेंट नीट वाचा. What is this theorem? If order of g is equal to p raised to n into m such that p does not divides m. ह्याचा अर्थ काय नीट लक्षात घ्या. p does not divides m म्हणजे या m मधून कोणताही फॅक्टर बाहेर येत नाहीये p चा. ओके, p बाहेर येत नाहीये. याचा अर्थ काय, या p चा आणि m चा जीसीडी 1 पाहिजे. ओके, कोणत्याही नंबरचा जीसीडी p सोबत कोणत्याही प्राइम नंबर सोबत 1 असतो. कधी असतो, जेव्हा त्या m मध्ये p हा फॅक्टर नसेल. ओके, सो हियर द जीसीडी ऑफ p आणि m इज 1. काही वेळेस काय देतात नेटच्या क्वेश्चन मध्ये वगैरे, समजा p रेज टू n into m such that the GCD of p and m is 1. It means that p does not divides m. Okay, then the subgroup of a group G of order p raised to n will be a sylow p subgroup. This is the sylow p subgroup. ओके, आणि ह्या सायलो पी सबग्रुपचा जो कोणी कॉन्जुगेट सबग्रुप असेल तो पण काय असणार, सायलो पी सबग्रुप. ओके, ओके, एनी डाऊट? आणि तो सायलो
No,
पी
sir.
सबग्रुप असेल मॅक्झिमल पी सबग्रुप असणार. ओके, look at it. Now this is the first sylow theorem. Let G be a finite group with order of G is equal to p raised to n into m, where p is the prime number and p does not divide m, where n is greater than or equal to 1, then that G contains a subgroup of order p raised to I for each I, and also every subgroup H of G of order p raised to I is normal subgroup of order p raised to I plus 1. म्हणजे याच्यामध्ये हा सबग्रुप काय असतो, नॉर्मल असतो. ओके, याचा व्हिडिओ मी टाकेन पुन्हा. कोणाला काही डाऊट असतील तर आपण 2:30 वाजता बघूयात. ओके, 2:30 वाजता सेकंड सायलो थेरम बघूयात. ओके, फर्स्ट, सेकंड अँड थर्ड सायलो थेरम झाले की त्याचे वरचे 7-8 एक्झाम्पल असतील. मग त्यानंतर आपला ग्रुप थेरी संपेल. ओके, त्याच्यानंतर आपण डिफरन्शियल इक्वेशन चालू करूया. सो एनी डाऊट इन दिस लेक्चर?
No, sir.
No, sir.
डाऊट असतील विचारतात. ओके.